Earth science time. Today we are talking about water. Water is one of the things of Earth. The study of water, I've already written hydro. What do you think the study of water is?
Hydrology.
Hydrology. And we're also talking about hydrogeology, which is the study of the interface, study of water. And this is the study of the interface between water and the land, and the earth, yes. So we're talking about hydrology and hydrogeology. I would say the most fundamental aspect of hydrology is the water cycle. So we're going to talk about that first, and really fairly basically. But we're going to add a few things that maybe you didn't know in third grade. And if you did, that's great too. The water cycle, round and round. The water goes up and the water goes down. So here we have some hydrogeology in the Greek, geos, and in the geos, and this is the hydro. Oops, hydro. Okay, you have to stop talking. You have to stop talking. You have to stop talking when I'm talking. I'll ask you when I want your input in the discussion. It's not right now. So we have here geos, the earth, and hydros, the water. Hydrogeology, and we're talking about the interface between those. We also are including the atmosphere. Up here is the, I don't know what color. Here's the sun. I'm not just including this because I think it's cute and it's making it like a child's drawing. Why do you think the sun would be included? It's not really, I wouldn't say part of the water cycle, but it's extremely important to the water cycle. Only? No, be more broader. To you that seems, yes. The sun provides the energy. The sun provides the energy for the water cycle, largely. What else provides the energy for the water cycle? No, not really. I was trying to make it so that would be true, but it just isn't. No. What other energy source? No, it's the same energy source as what most of our erosional media were. Gravity. So between the sun and gravity, the sun, we'll say this, the one process that the sun can do is when liquid water on Earth's surface, it'd be better if you were taking notes. When liquid water on Earth's surface becomes gaseous water vapor, that process is called, so it becomes vapor, that process is called evaporation. Broadly, we could call it vaporization when it becomes vapor, and that would also include boiling. But this process of evaporation is when water at below its boiling point, some of it does evaporate. Some of it, it strikes an equilibrium between the vapor pressure in the air and the vapor pressure within the water. And something we talk about in Chem 2, but we don't worry too much about it other than that the liquid water becomes water vapor. And it's very important that you know that water vapor is invisible. Are clouds made of water vapor?
Yes.
Nope, they're not. Water vapor is invisible. What are clouds made of then? Yeah, liquid water droplets or ice crystals. Clouds are not made of water vapor. The water vapor is invisible. If you have ever boiled water and you see the little curls of steam coming up, that's not water vapor. That's water droplets recondensing. The water vapor is invisible. So this is important for you to know, and you also didn't know it, so it's really important for you to know. Yes?
Then how do clouds float and stay afloat in the sky?
Yep. So the water vapor, what process could cause that to become liquid water again? Condensation. Becomes again liquid water in clouds. Why do the clouds stay afloat then?
Suspension.
Yeah, they're suspended in the air by two things. One, even though we think of water as being quite heavy, they're not suspended by gravity, the opposite of that. Like if we have this jug of water, if we think of water as being fairly heavy, but the water droplets that make up clouds are very, 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 very widely distributed. And so even though a cloud, it's a kind of cloudy day, but if you think of like a puffy little cumulus cloud, there are different names of clouds, which we probably won't talk about this year, but I have talked about in the past. But a puffy little cumulus cloud you might see on a summer's day that looks kind of like this, that can weigh about 1 million tons, literally 1 million tons, and they are huge. They would be larger in area than the town of Crawford. The reason they look small and fluffy and is because they're a long ways away. That's how things work. The farther away it is, I don't know if you've ever noticed this about the world, but the farther away something is, the smaller it looks to your little eyes. And so these are actually very large. They're very, very large, and they're also quite massive, but they're spread out over a large area. And so, even though the water is heavy, it's suspended by air currents. It's suspended by its relatively, the cloud itself would have a very low density. Does this kind of make sense to you?
Yes.
Not water vapor, and they're actually very heavy, but they're extremely large. Yes.
Did you know that it's illegal to skydive pretty flat?
Who's going to stop you? Okay.
It's just illegal.
Because it's liquid water, yeah. And there are different kinds of clouds, but that's not what we're going to talk about today. And then, but sometimes you'll recognize, viewers, that the water, whether liquid water, it can also freeze up here to become ice. Sometimes the liquid water does fall down under the influence of gravity. What do we call that?
Rain.
No.
Snow. Sleet.
You're being way too specific. You said a lot of them. Precipitation. Precipitation. The word precipitate means to fall. Something you might be aware from your vocab is that a precipice is a cliff, and that word just means, like a precipice means something you're going to fall off of. Precipitate means it's falling down. A precipitous occurrence is one that seems to have fallen from the heavens. Like, oh, I won the lottery. How precipitous. It just happened all at once. It fell down on me. Precipitation. When we are in the labs, you remember from chemistry, if you took chemistry, a precipitate is the solid that forms from a solution. It falls out of solution. The root word of precipitate is the Latin word for to fall. So the water or snow or whatever, well, it's water in both cases, the rain or snow or sleet or hail, all of those water falling out of the sky. Yes.
I love that our notes for this class is just deep child's drawing with science words all over it.
Yeah. That's what earth science, that's what all science is. We're trying to look at the world as a child would look at the world, with our curiosity applied to it, and with Mr. Kyne's vocab applied to it. So it's more manly. Yes, Hunter.
How are like clouds today are like because they're still liquid.
Mm-hmm.
How are they liquid?
It's
Really bad question.
yeah, I think I know what you mean, though. Probably they're ice crystals, first of all, which doesn't really matter for this. I mean, there's a difference. But instead of being these puffy little clouds, it's like this. It's distributed over a much wider area, and they're probably, I would guess, I'm not sure, but I would say probably less dense. And so it's over a larger area, and it's less dense. And what is keeping it up, though? That actually is a really good question, because what's causing it to fall down is gravity, but air pressure and air currents are keeping it up. Basically, even though it's cold today, the ground is warmer than up here, and so the air is constantly convecting up, and that buoys the cloud up, is one way. Another way is that there's just higher air pressure down here, and so it's kind of like, I actually have a great example for this. Oh, wait, where did it go? Oh, it's under your chair. I have a great example for this. So because I blew this ball up with my lungs, there's relatively high air pressure in here compared to outside. And if I try to press it, like even if I use gravity, like if I drop stuff on it, it won't compress. And that's kind of what's happening here. So this air in this layer here is higher pressure. And so even though the cloud is heavily sitting on top of it, it can't get down. It can't press down because of the air pressure. That noise is the sound of air pressure. Does that make sense to you?
Yeah.
So why does the cloud stay up? A combination of air pressure and air currents, largely. And secondly, does it always stay up? No, precipitation exists.
Why? So is drought, because like there can still be...
So this mostly, we're still talking about the water cycle. Drought is really more of a climatological thing. So something, a pattern over a long period of time where precipitation doesn't happen because of some disruption in this, I would say. So the normal, in most areas, the normal pattern is this. To varying degrees, it can speed up and slow down depending on where you are and what time of year and so all that stuff. But usually there's some of this, and maybe in like a desert, this cycle takes a really long time. So there's very little evaporation, so there's very little condensation, so there's very little precipitation. And maybe in like a rainforest, it happens extremely fast. Lots of evaporation, lots of condensation, lots of precipitation. Yes.
Right. But like on drought years, there's still huge thunderheads that are full of water.
Yeah.
So why is it not coming?
Why? Exactly like what I just said. The question was, how come if maybe there's a big old cloud, but the rain does not fall out of it, the part you're missing is at that location. Eventually it will. Everything that goes up falls down. Yeah, so maybe it's because the air pressure is really high here, and so the cloud kind of just moves over it, and where the air pressure is low, now it's going to dump its load, as it were. Yes. Kesslin, you had a question.
Well, he was dry.
Oof.
He played at that.
The cloud.
No, those are things.
What?
You're really adding me today.
Uh-uh.
Okay,
Yeah,
here's an important part of this. This precipitation, I'm going to finish this. We're going to make that into a lake. 3 things can happen when this precipitation hits the ground. 3 things can happen. 3 things. Well, this is just a list of 3 things. 1, what's one thing that could happen when that precipitation reaches the ground?
Puddles.
Okay, I'll count that. I'm not going to count that.
Why?
Wait.
I might get wet.
Where- Let's look right here. When this water gets right here,
It'll fall
3 things can happen to it.
it
1.
freeze
Where could it go? Where could this 1 drop of water go?
down.
Be more specific.
To the next watershed.
So you're saying it might, where's the next watershed? It might go there. What would we call that? You should know this word, runoff. One thing that can happen when water interfaces with the ground is runoff. It goes downhill. It moves downhill. 2, what else could it do? Evaporate is exactly right, Ethan. It could just return to the atmosphere, evaporate. And thirdly, what else could it do? No.
Freeze.
Erosion might happen as it runs off, but that's not what we're talking about. That's not what the water's doing. Where else could it go? Where else can it go? This little drop of water.
Soil.
Okay, let's not call it absorption. You're right, but we're going to call it this word, infiltration. It filters into the ground. It filters in, so it's infiltration. Like Among Us. When the Among Us fellow, I don't actually know how this game works. When the Among Us bad guy, what's his name? Imposter infiltrates into the group. I'm trying to reach you on your level, which is that of an idiot. When the imposter infiltrates into the group, he has filtered in. He has become part of it, and that's what infiltration is. I don't actually know. Or when you're playing Dress to Impress.
and then randomly wins first place for
Yeah,
not even having
as a
to
joke. Yeah.
Or
Me when I'm playing Dress to Impress and the noob wins as a joke.
when you're playing that one little game.
No, learning from.
Where you're analyzing all the germs and stuff.
Yes.
And the octopus guy infiltrates in and he catches on.
I didn't even know that part happened. Okay. So after the water, this is very important that you know that these 3 things can happen, and then these go to different locations. So the evaporation one returns to the water cycle as such, right? The evaporation one goes there. The runoff one is like what we talked about in the last video. So maybe it does include some erosion. So maybe some sediment goes with it. Today we're talking mostly about infiltration. What happens when it goes down here? What we call, this is the main point of today's lesson, the groundwater. Do you see how, I hope you see the relationship between these 2 words, hydrogeology and groundwater. Hydrogeology is the study of, water and the ground, and groundwater is water that's in the ground. So hydrogeology is effectively the study of groundwater. No, be quiet. An important thing for us to know about groundwater is that if we took a section of this ground right here, let's say we take this section, I'm going to try to draw it like that. There's a section, which in geology means it's a cross section of the land. And in my drawing, so we've taken this section, put it down here. There's going to be several little places. So depending on the type of material this ground, the geos, is made out of, maybe some of that water has infiltrated. Okay, let's assume that it has. Let's say that this kind of rock is porous. That's a word you need to know. Porous. Absorbent and yellow and porous is he. Who's that set of? SpongeBob SquarePants. And what does porous mean? It means that he contains, no. Holes. Pores, yeah. Some of you have more pores than others. Some of them I can see from here. Get your pores under control. Some rocks are porous, especially sedimentary rocks. Not every sedimentary rock is porous, but most of the porous rocks that we commonly encounter are sedimentary. And so in this case, I'm going to be using sandstone. So let's say this ground, this geos, the bedrock here is sandstone. Okay, so that's all sandstone. And underneath it is, let's say, shale. These symbols mean sandstone and shale. You should probably write those down. So this one is sandstone, which is porous, and this one is shale, which is not. Oops, I don't mean to write the word not. That one's shale, which is not. So how far down will the water infiltrate? No, that's exactly it. Will it go all the way to the core? No. So what's going to stop it, basically?
The mantle.
I just said the shale is not porous. So this we call an aquiclude, meaning it excludes aqua, which is water, or an aquitard, which means it slows down water, depending on which one it's doing. An aquiclude stops the water from flowing through, and this one slows the water enough that eventually it will stop. And so the sandstone, though, you'll know this word, this sandstone can hold the water. It furs the water in Latin, so it's an aquifer. It holds the water. It holds or contains the water. Okay, so in this example that I have drawn here, this aquifer, the sandstone, below the water table, we call it the level at which the water rests, the water table. Have you heard the word water table before? That's the zone at which the water is resting. And something important about this diagram is that the surface of this lake is even with the water table. Unless it is currently raining or shortly after rain, this must be true. So the level of the water table is contiguous. It's a straight line with the level of the lake. So down here, all this is soaked with water, like a sponge would be soaked with water. And we call that the zone of saturation.
Can you put a little fishy in the water?
Yeah.
Zone of saturation. And above this, where there is no water, where there's not as much water in between the grains, is called the zone of aeration. Meaning there's air in them. And that's an important part, is that in a porous rock, the pores are never empty. They either have water or air. So the zone of aeration is where they have air. It's above the water table. Above the water table, the pores have air in them, so we call it the zone of aeration. Below the water table, they're saturated with water, and so we call it the zone of saturation. So an important part of this is that groundwater, as I said before, is contiguous with surface water. Where there is one, there is the other, as long as there's aquifers around. So think about, have you ever walked on the trail that I walk on, where there's the river?
Yes.
The river is surface water, right? It's water on the surface. And the land around it is porous. And so people, a lot of times when they're mistaken, think that in cross-section, if they think about this at all, which they probably don't because they're stupid, they think that the ground is just like a Tupperware container and the water is running through it and it's just holding it up. But that is not the case. All over the place, the ground has water in it at the same level as the river. So if you went on that walk that I go on, and you dig down to where the same depth as the river, it's like kind of like this. Like the trail's up here. This is where me and my dog are walking.
That's so cute.
People think that this is just like a Tupperware, I have to go here to get some water. But really, if I dug down this far, I would get to water, because the water table is there. It would be water in the dirt.
Or is it sometimes?
It varies, but yeah, I mean, the level of it might be kind of like, depending on how recently it rained and stuff. But it goes the other way too. Where did this water come from? People think the mountains, that it all just runs off from snow melt from the mountains. No, but it came from the ground. The last time it rained, some water went into this, some water infiltrated into this ground, and it slowly trickles back out into the river, which it's contiguous with.
True for anywhere, like if I'm
Most anywhere.
next to the river?
If the ground is an aquifer, it is true, yes. That means if the ground is porous enough and contains water, yes, that is true. An important thing to note is that, unlike what I thought until I was literally in college, an aquifer isn't, or at least doesn't have to be, like I always picture just that level from Super Mario 64 where you fall down a hole and there's an underground lake with a monster in it. this is what an aquifer is. And in fact, I mean, seriously, I was like embarrassingly old when I found out this is not the case. And when people would talk about the Ogallala aquifer, I pictured underneath basically this entire part of America was a huge hole with a lake in it. And that's just not the case. It's much more like this. It's sand. It's basically a sandy old sponge, and that's what's there. It's not a giant hole. Now, this is a good segue because this does exist. What do we call this? You know?
Hole with water in it.
This is one of your vocab words. A cave, yeah. I would say cavern. But yeah, this can exist. It's not usually that way for an aquifer, but this does exist, this cavern, and it exists from this. Let's say that this block is probably, I've said this before, who knows what this rock is going to be that surrounds it. Not sandstone, not shale. It's not today I didn't say it. I said it back when someone was doing it. No. What rock? What? Limestone. It's limestone. Bedrock is not a kind of rock. It's limestone because limestone does what in water? Especially acidic water. It dissolves. It dissolves. It absorbs into the water, dissolves in the water. And so what happens is maybe in time 1, whatever that means. Oh no, I've done it so wrong and stupid. You are so worthless. You need to get out of here with your stupid trash. Okay. It actually needs to be like this. They need to be offset from each other. Yeah, get him. That's what. So these need to be offset from one. So this is limestone. There's some imperfection. There's a crack in the limestone. Water gets in there and dissolves, and it makes a hole. And then more water gets in there, and more water gets in there, and eventually we end up with a cavern. Interestingly, some things can happen in this cavern. As the water continues to run down, it's absorbing limestone, and as it drips, what do you think is going to form here where it's dripping? A stalactite will form where the water is dripping. And then where it drips on the ground, a stalagmite.
And it can form a column.
Stalagmite, stalactite, and if they do meet, we call that a dripstone column. I hope someone's writing any of this down because it seems like most people are choosing not to write anything, even though I spent a lot of my energy and time and spirit writing this, and some people are writing almost nothing.
Like Minecraft.
Hey, guess where I learned this from?
Me?
Dinosaur training.
Mm.
I learned this from Minecraft.
Yes.
I went to the Karchner Caverns in Arizona, and they were really cool. Like huge. There was
Yeah, I think these are really cool.
It is really cool.
I really like this.
Now
Here's what else can happen. Here's what else can happen. You'll recognize that as this water is rolling down here and dissolving, it must necessarily, eventually, get the ceiling higher and higher and higher. And at some point, look, yeah, at some point it's going to fall, especially if Carson's driving his truck over it, something heavy. And then what's this called? When this all comes in. I don't know what you're talking about, but it's called a sinkhole in English. A sinkhole.
When we went to Mexico,
It might be cenote. I don't know Spanish that good.
they're pretty freaking good.
Yeah, and if there's a whole series of these, when this happens over a very, 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 very large area, over and over again, we end up with these, I should be doing this in brown, we end up with these basically spikes where the majority of it is negative space of caves, and it forms these spikes kind of like in Mario, and this is called, you should write this down, this is called karst topography. And probably your cenote, if I'm understanding this correctly, is probably just an area where there's lots of these and they're filled with water. And they're just lakes. And it can be various degrees of spiky. I think I've said most of what I want to say. Do you have questions about any of this?
I wish.
Yeah, I do too.